Good afternoon, everybody. Welcome to the Healthy Indoors Live Show. I'm your host, Bob Krell. I'm the founder and publisher of Healthy Indoors Magazine, and I'm happy you're able to join us today. We have a good group of people in our virtual studio audience, and of course, many of you are watching us on social media, Facebook, LinkedIn, YouTube, the like. So welcome to everybody. We're happy to see you. Today's topic, we'll be talking a little bit about some effective solutions for indoor air quality issues in buildings, which is kind of a continuation of topics we've been doing for the past several weeks. So we're real excited to continue that conversation. With us today is Jesse Coiro. He's the Director of Growth and Strategic Initiatives at Lab. Jesse has over 20 years of experience providing solutions to the biopharma, pharmaceutical, medical device, and educational markets, with his specialty being focused on filtered solutions for the protection of personnel, facilities, and the environment. Jesse has also experienced working with hospitals, helping develop plans to adhere to the USP 797 standards, while also providing solutions such as environmental monitoring, sterile processing, and proficiency testing. So a lot of stuff there. So we're really we're pleased to have Jesse. Thanks for joining us.
Thank you, Bob, for having me. I appreciate it.
How are you? Yeah,
doing well.
So you're coming to us from somewhere in Massachusetts. I forget the city.
Raleigh, near Newburyport, North Shore.
Okay, great. So, one of the things, many people in the audience may not be familiar with, some of the things that you've been involved with the Lab, and I know we've had some discussions over the past few weeks leading up to the show. Yeah. But your company is predominantly been focused on dealing with the laboratory environments, right? Tell us a little bit about that.
Yeah, for sure. Lab, we started the company in 1970 as a provider for filtered solutions for portable laboratories, really trying to integrate solutions where we can have flexibility and portability in the laboratory with ductless fume hoods. Many people in the lab industry understand ducted fume hoods. It's really where you extract chemicals and you throw them out into atmosphere. And we invented the first ever ductless fume hood so we could capture and contain within the fume hood and not throw out pollutants out into the atmosphere. Fast forward 50 years later, here we are today, and we have big initiatives moving forward with helping buildings implement and achieve LEED certification in zero net energy. And filtration is the heart of what we do. It's part of our DNA at the molecular level and at the particulate level. Today, a year after the pandemic, we knew we had technologies available that could help develop and implement as mitigation strategies in buildings without the costly upgrades to HVAC. And that would be the Halo system above me. And that's it's a HEPA filtered H14 system that really truly provides mitigation solutions for particles, viruses, viable particles. So, that's what we're focused on today in the health and healthcare division, but we still very much focused in the laboratory world.
So, obviously, 2020. Well, first off, you're in a really robust lab, and at some point we'll have you pull back and show us the whole place, because it's an interesting facility that you have there. It's a training facility and basically a demonstration facility, which is working nice for the show today, by the way. But you had plans, and again in your target market, and suddenly we have a pandemic last year, and that did cause a bit of a shift for you guys, correct?
Absolutely. Yeah, first of all, everybody was concerned about their business, what's going to happen with all the shutdowns. If people aren't using laboratories, they're not using fume hoods or storage solutions. And so, we had to kind of reinvent ourselves in a manner of how can we introduce the technology as an indoor air quality solution. And that was really where the Halo came to play, which has been part of our portfolio since 2014 to capture and any type of emissions in the laboratory on the VOC side, acid side, and formaldehyde side, as well as on the particulate side. And we knew for sure, just CFD and all of our test results, that this product was absolutely going to reduce and provide dilution equivalencies within the facility, drastically reducing the transmission risks of any virus, including SARS-CoV-2, but also influenza and other airborne viruses, in addition to improving overall indoor air quality. So yeah, it's been a change for us, for sure.
I mean, challenging. I mean, from where you're coming from with the laboratory environment, I'm kind of in awe of the fact that you actually have technology that can let people work in laboratory hoods and exhaust that processed air back into the space.
Yeah.
I wasn't really aware that even existed, to be honest, prior to us meeting that type of
Yeah,
technology.
for
Because I
sure.
always thought everything was shot outdoors.
Unfortunately, the majority of it is. No, and when people see us at a trade show or an event or in a live show like we're doing today, they think of us as a new company. But no, 53 years later, this is all we've been doing. We don't duct anything or throw anything out into the environment. It's a complex technology. It's based on molecular filtration, and we have to understand what our limitations are first and foremost, so that we can ensure and guarantee safety within the labs that we install the product. It's very complex. We have to test and validate all of our products according to most stringent laboratory standards. Um, so yeah, it's very interesting. On the particulate side, to be honest with you, it's easy in comparison to the molecular side. You know,
Yeah. Well, yeah, and I assume it would be, right?
yeah,
Particulate. I mean, we have, HEPA filtration technology, the impingement type filters. I mean, they're effective at grabbing particles.
yeah, for sure, absolutely. You have to understand the way HEPA filtration works. It's fairly simple technology. There are many different rated HEPA filters. There's H14, H15, then you get into ULPA filtration, and of course, as we all know, you have MERV filters too. It's about the overall efficiency and the effectiveness of capturing particles down to a certain micron size, as we know. Again, fairly simple in comparison to understanding thousands and thousands of molecules, how they react to one another once you're doing reactions inside of a fume hood, how they react within the carbon bed. So it's interesting on all fronts, to be honest with you, because you learn a lot as well in these different markets. We're providing solutions to industries we never thought we would be involved with, like long-term care facilities, retail space, schools outside of the lab, K through 12, Head Start programs, Title I schools. It's really opened up our eyes a lot to a lot of the challenges they're facing. How they're trying to comply with ASHRAE and CDC guidelines to the increase of air change rates, upgrade to MERV 13 filters, the impact it has on their bottom line, and the impact it will have on the overall operational expense. Not many people recognize that because there are guidelines in place to help with mitigation, but for school settings and even nursing homes, it's almost impossible for them to achieve those type of recommendations simply because their HVAC is not equipped to do so.
Right. I mean, because it's a major, it's all well and good to say, hey, bring more fresh air ventilation and, put higher efficiency filters in. But if your equipment doesn't have the capacity to do that,
Yeah, you
that's
can't
not
do
an
it.
option. It's really not.
It's not an option, and that's really what this product does. It's a supplemental solution to your current HVAC, and it's a permanent infrastructure solution. As you see, ceiling mounted. It's tied to the electrical. It can't be shut off accidentally. It provides very predictable airflow patterns, which is critical to reducing load concentrations. And we've done a number of different studies both in controlled atmospheres and then in real world settings, which is really peer reviewed data, which we want to look at to understand the true efficacy of this product at reducing concentrations, because that's ultimately what we need to do. We want to provide dilution equivalencies to traditional air change rates that an HVAC system will be able to provide you with.
I mean, so there's another factor that I just seems to come to mind. If you're able to create those dilution equivalencies, right? The ventilation equivalencies
Yeah,
with that, there's got to be some net energy savings, right, to an operation on a building, as
for
opposed to
sure.
throwing the air outdoors, right?
Absolutely. These run on 50 watts of energy. When we talk about the increase in air change, you want to try to open up your dampers to 50 to 100% if possible to let as much outside air in as you can. You have to look at the cost implications involved in that. I'm working on with the school district specifically here in Massachusetts that did all the right things, and they upgraded their HVAC system and they opened up their dampers to 37%. That's all they could do. And they saw an increase of their energy expenditure month over month to about 54% increase.
Which
So
is huge.
it's
That's huge.
huge and it's not sustainable. And my fear is that a lot of these school districts, if they can and their budget allows, they'll upgrade their HVAC system, which is fine. Great. You should upgrade it anyway.
Sure.
But in order to maintain the right air change rates, the proper outdoor air as, ASHRAE and CDC recommends, it's just not sustainable for these schools and their budgets. So they're going to pull back. They'll do it at first, and then, everybody's going to be complacent. And, we'll
Right.
pull that back a little bit. We'll now shut our dampers a little bit more, and a little bit more, and we're going to save more. And ultimately, all the cost upgrades that they've done to their system is going to be for nothing. And we don't want that to happen. With this system, again, 50 watts of energy, you're looking at about $1 per day running 24/7.
Which is bad.
Very sustainable.
Well, there's another factor too. Like even if you have the ability to open up dampers and bring a lot more air in the existing mechanical equipment, and yes, there's obviously a substantial energy penalty, but the other factor is most of these systems are not really designed to handle that additional latent load that you create. By
Right.
you're able to heat and cool. Equipment can be pushed a little bit beyond with the heating degree days and all that, but
Right.
you don't have that latent moisture removal capacity. So the other problem is if you start to open up
Humidity.
your outside air dampers, you're going to make your building swamps
You
potentially.
absolutely. There's a lot of implications in doing that. So, we feel, again, a lot of engineered control systems can work together to develop the best mitigation plan. Nothing is a silver bullet, right? And we have to understand that. But it's how they work together. And so we should, if we can, increase our air changes with our HVAC system, but you must have proper filtration. You must have predictable airflow patterns in order for it to truly work. If you're just increasing airflow to increase airflow and you don't have the right airflow patterns, you create a turbulent environment, you don't have the right filtration, you can re-entrain all the potential contaminants back into the atmosphere, into the ambient room. If you're letting more outside air in, you have to understand what the implications may be from the polluted outside air coming indoors. So there's a lot of implications that need to be looked at when you're trying to truly develop these strategies.
Well, I mean, we certainly, I think many of us, many people out there labor under the pretense that outdoor air is necessarily fresh air. And that, certainly that's not the case. I mean, in
No.
urban environments, many agricultural environments, that's
Right.
not the case either. And, certainly outside of, North America, outside of the US, I mean, it's not even a feasible option. Places like India and, your downtown Beijing, bringing in more outside air, that's not an option. That's not
No.
better air. That's worse air.
It's worse air. Even on the West Coast, you look at the wildfires.
Sure.
It's not an option. And we've worked with many accounts that they've had to literally evacuate their buildings because of the wildfires, because they're trying to let as much fresh air into the building, and it's detrimental to what they're trying to do. So yeah, there's a lot of there's an impact with everything you do, and you have to understand what all these different changes can do to your building, from humidity to temperature control to what type of pollution you're letting in your air. Yeah, there's a lot there. So we want to be a resource to companies to truly educate them on what products really do, the true efficacy behind the products, and how, again, they can work together, and what the potential impact would be if they were to upgrade their system. And just educate. That's the best we can do. And, we're seeing a lot going on in this industry today that we're not happy about. There's a lot of falsified information, but, at the end of the day, it's what can we do and to be a resource, and that's what we have to focus on.
Well, a guest we had on a few weeks back, Vinny Lobdell, made a comment that I think is very true. Is that there's a lot of technology, and no technology is bad. It's just that it's a lot of times things are misapplied, and
Right.
and there's no, like you said earlier, there's no silver bullet really. There
No.
is not one solution, right? And Vinny stressed that a few weeks back too.
Right.
Is that there isn't a single solution. You really have to evaluate the environment you're trying to address, what you're right, what are the constituents you're dealing with there, and
Yeah.
that goes back to being an IAQ consultant. It's the same mindset. You come in, one size doesn't fit all. There's not a single solution out there.
Absolutely. And it's funny because we get requests, and can you just provide me a quote? It's, yes, but no, we have to truly understand there's a lot of different dynamics we have to be aware of, right? What's the size of space, the cubic volume of air we're looking to process? What do you have as far as air change rates? What's the CFM coming out of your supplies, and what's being sucked up in the returns? And there's a lot of implications involved there. Where are they located? And then we can provide the proper positioning. It's not just stick a product in the corner of the floor and you're good to go. It's much more than that. And when you're dealing with a true professional, you understand that it's much more than just sticking a filtered solution somewhere in the room and calling it a day.
Well, I mean, that's the same issue for consultants too. People in the in the indoor environmental space. You get a potential client calls up and goes, "Can you come out and test our air?" and tell us if it's good. It's like,
Yeah.
come on now. We
Right.
kind of do need to zero in on, what's going on.
Yeah.
Why are you asking for this? What are the underlying situation, or,
Right.
circumstances, and what are you trying to achieve?
Biggest question I ask, what are you trying to achieve? Are you looking
Exactly.
to increase to 8 air change rates per hour? Or are you good at the 3 to 4? What are you looking to achieve? And we can develop a plan that's going to work for you, but we don't know what you're looking to achieve. So just to throw a quote out there, it's really not how we want to do business.
Yeah, and that's, you really can. And I think that's a
No.
global answer for indoor environmental issues. There is just,
Yeah.
uh, what is good is so subjective anyway. But one thing you did mention, and you touched on, and I really want to elaborate, and have you elaborate on it a little bit, is the fact, it's not just a matter of even creating those air changes, right? It has to do with also airflow patterns and distribution, because
Yeah.
obviously, if you're doing air changes, you have all this great air change capability in a building, but it's all happening up at the ceiling, not in the occupant's breathing zone. That's all well and good on paper, and mathematically it looks fantastic.
Yeah.
But in reality, that it's much more complex, right?
It's much more complex, and you have to understand. We'll talk about SARS-CoV-2 because that's the biggest topic of discussion today. But you look at how these viruses remain suspended in the air. They stay. Once these droplets are released, they then desiccate. They become droplet nuclei, and they stay suspended in the air at about 5 to 6 feet in space, right at the breathing zone of the occupant. And we don't want to take those pollutions and subject somebody else to those concentrations with a filtered solution that's behind them, in the corner of a room somewhere. We want to take those up vertically away from the breathing zone as quickly and as efficiently as we possibly can. But then when we disperse air, we also don't want to create a turbulent zone. So we want to create a Coiro.mp4 effective airflow, which I'm sure you understand what that is. It's a very predictable airflow pattern. So we take the dirty air up, we disperse the clean air out horizontally, and then we just create a clean curtain continuously. So it's very critical how these airflow patterns are achieved, and the importance of how that's going to really determine the true efficacy and the effectiveness. It's about reducing that load concentration.
So
Everywhere, not just
yeah, and that's, I think what you're hitting on here is really important. Is that is what's the net effect, right?
right.
Again, and this is true for any technology, any device. Like the device can do, X, Y, Z. That's all well and good, but what does it do in that space now that you're actually implementing that as a solution? And what's happening? What's the net effect in the space? That's critical,
Yeah,
right? That's the
it's
difference between
critical.
being overly successful or just being marginally successful.
Or providing a false sense of security to some. Yes, we provide H14 HEPA filters. It's a very robust HEPA filter. We can also integrate ALPA filters in the system. It's only part of the story. The HEPA filter, it's been tested at EN 1822 standards. It meets all criteria, but it's how effective is the unit at ensuring that filter is going to capture and contain the viruses or the pollutants present in the facility. We have, like you said, we have to understand what it does in the space, not just what the product can do in a very controlled chamber, right? And we have testing studies done. Yes, we had a testing controlled atmospheres for MS2 bacteriophage testing to understand what the load reductions were. But we also wanted to test them in real world settings and challenge the system. So much so we actually installed 8 units at a very large shoe warehouse on the West Coast called WSS at a 186,000 cubic foot facility. Only 8 units. Now, every unit's rated to provide about 3.5 air change rates based on 3,500 cubic feet of space. So we're looking at that and say, okay, how we worked with a IAQ specialist on the West Coast. How can we work with their current engineering control systems currently that they have in place, integrate the Halo in parallel to their returns, and get this to really achieve the results we're looking for. And what we thought we were going to see was about a baseline reduction of about 20 to 30% of particles, between 0.3 micron and 5 micron in size. And ultimately, we saw a reduction of greater than 80% across the board. And this is a store in Los Angeles, so the air in general that's being entered into the facility alone is not the cleanest. And it just shows the efficacy. And you don't really know what it does until you challenge it in settings like that.
But that's true with any technology, right?
Absolutely.
It's laboratory results they're a
They're
benchmark.
controlled.
They're
They're
a controlled
benchmark, right?
benchmark. I mean, years ago I was involved with research on air duct cleaning with the EPA,
Hmm.
and we did first a controlled lab study at RTI down in North Carolina, and everything, the results were like these always remarkable results. And it's like, yeah, except this isn't what it's like when you're crawling into a crawl space and and you've got configurations that aren't built to code and things aren't right.
Yeah.
The real world is like,
Hmm.
are you getting that same result? And, truly,
Right.
in that pilot study, it showed the difference between the lab and the field were like night and day. What happened? It's just totally different
Yes.
results.
Of
But
course. It's unpredictable, right? When you put it in an unpredictable setting
well, you've got
versus a
more
predictable
variables
setting,
when you're
it's much
looking
more
at, with
variables.
anything. Again, I'm not citing anything singularly here, but I mean, you look at anything
Anything.
in a laboratory setting in a controlled setting.
Yeah.
Part of that process, right, is to have controlled parameters. You don't have a lot of variables. You want limited variables so you can study. But when
Yeah.
you get out in the real world, the parameters, kind of they dictate themselves. You don't really get to choose your real world parameters. They're
You
there.
don't. You don't. And that's the best data you can have, as far as I'm concerned. You have to do the lab test. You have to do those studies for sure. But the best data you can obtain is that in a real world setting and have real paired review data, so to speak.
Yeah, I would think. Yeah, I think the lab results are in most cases are best case scenario. It's
Yes.
what capabilities of whatever this is can do. In a lab. Okay, great. That's what it's
Right.
capable of doing if everything goes right.
Everything's perfect,
Yeah, yeah.
absolutely. We've actually tested the system in a positive COVID-19 patient's room at a long-term at Avamere Healthcare Associates. We have a case story on our website. And we had a room that was right next to that room that had another positive COVID-19 patient in it on the same centralized system. So they were fed the same supply air. And we really wanted to understand what the reduction was in the airstream and at the return vents. So there was PCR tests performed. We ran swab samples around the bed of both patients, swab samples on the window shelf, and swab samples at the return. The patient in the room with the halo was just at the start of their quarantine or their isolation, and the patient in the room without the halo was towards the end of it. And we knew that because of the viral shedding, right? Everybody's going to shed viruses differently depending on the level of infection. So the patient in the room with the halo was shedding a tremendous amount of virus. And we know that because when we ran the swab samples for the droplets that are going to fall, there was 23,000 copies of RNA at the foot around the bed and 812 on the Windows shelf. With the room without the halo, there was non-detectable. However, in the return, in the airstream, we found 3,500 copies in the room without the halo and 0 non-detectable in the room with the halo, which proves again the efficacy of what it's doing.
It's happening in the air. Yeah, yeah.
It's cleaning the air and those those droplets that are remaining suspended, which is the greatest risk of transmission. We could talk about that as well. We're very focused on transmission, formite transmission and contact transmission in close proximity to one another. But the biggest problem is the air. It has to be addressed. And it's frustrating today because, we're now talking with many different companies. People are becoming complacent because of, well, it's 14 months and I think that's just natural,
Sure.
way
Yeah.
humans react, but also
We all are
we all are.
a
But
little
there's
bit.
also vaccine complacency. And that scares me because we have the P1 variant, the C37 variant, and those are just two variants that are now seen in South America that we don't know how we're going to react to that when we're vaccinated. And it scares me. I don't want to become complacent.
And nor should we, Jesse. I'm telling you,
We
I
should.
just right before the show, I had a conversation with someone who had been a guest on our show last year, Barun Agarwal, in New Delhi, in India.
Yeah.
I just was actually
Yeah.
on WhatsApp with him, and it's horrible there. This is like,
It's
don't think for
brutal.
1 minute that this whole pandemic globally is over. India is now facing a crisis, an untold crisis. Okay, it looks like ground zero in New York City back last
It's,
April there.
oh, it's so
and,
scary.
and and maybe even worse because they have many more people to deal with and they don't have the resources. They don't have
No.
enough oxygen. They don't. I mean, it's just it's a real dire situation. And this, you're right. I think we in the United States are getting a lot more complacent.
Unfortunately,
You
I
know, I
see
mean,
it.
it's you're tired of it,
It's
and
human nature.
most of us have weathered it okay. Which unfortunately, there's nearly 600,000 people that didn't weather it okay. They perished,
Yep.
and probably millions more who have long-term effects. So this is, yeah, can't be complacent at all. It's unfortunate that that's happening though, because I'm seeing it.
Yeah, and yeah, I am too every single day, and it is for somebody who's trying to help provide a part of the solution. It's very frustrating because you get well, I don't know, what are our competitors doing? It's like, well, wait, but we're looking at this completely wrong. It's not about what are our competitors doing. It's about what
Right.
can we do better. We need to learn from our mistakes. We as a country, as a society, we have not addressed air quality appropriately.
Well,
There's not
ever.
ever. There's,
Ever our schools,
there's,
the problem in the schools now that everybody's worried about COVID and the pandemic, schools
yeah.
have never had good air quality.
Oh,
I mean,
probably the worst. And yeah, it is, there's no regulation on the market, and you just want to see something be done. I want to be able to look back and say, okay, we learned from our past mistakes. We're doing it a bit different now, so that and I hate saying this, but it is the truth, when the next pandemic comes, and it's going to happen, we are better prepared than we were before. And we don't go on this massive lockdown. And maybe we can now, okay, we will have to lock down a little bit, but maybe buildings can stay at 25% capacity because they've addressed the air issue.
mhm.
But you also look at, it's not just a virus, it's just indoor air quality. And you look at that alone as a pandemic. 300 or 400,000 people die a year just here in the US because of air quality issues, and contributing to asthma,
Yeah,
cardiovascular.
ultrafine particles that are
Oh my gosh.
rampant. Yeah,
It's just learn. Let's just learn from our mistakes, and but it's
but
not
do you think we
happening.
will? I hate to pose that question to you, but I mean, it's like,
Oh,
because I have serious
I have
doubt
concerns.
that we are going to learn from this. It's like, and it seems like we're almost in some ways doomed to be Groundhog Day, like the movie, and just keep repeating it. And that
Look,
would be sad. That would be really sad.
I have a lot of concerns as well, and I kind of can. I mean, we see it in the lab world. With filtered solutions, they're just we're so tied into tradition. How have we done things traditionally?
Mhm.
That's the acceptance. That's what we accept. We don't accept newer technology because we fear it. We should fear the traditional technology because it's not doing what it needs to do for today's world.
Well, we fear
And
change in
we fear
general.
change.
Humans fear change.
And it's
Humans don't like change, and they like to
the
follow. They like to be in a group. They like a group of people that agree with them.
right. So we
Yeah.
need somebody to take the bull by the horns and be the leader. Show how it's done, and but like you, I'm hesitant to say yes. We're going to learn from the mistakes. I don't know. I don't know. I hope so.
I've just seen so many examples in my career in the indoor environmental field as a consultant, going out and working toward a solution, like at schools or different places for a specific, let's say, a mold problem, and it was a
Yeah.
structural problem, and then they go and they re-engineer and spend millions of dollars, and they screw it up again,
Yeah.
and 2 years later, we're getting called again to go back into the same facility that's having a
So
different problem, but still related to the fact that they didn't learn a damn thing the first time around. We're back here again. It's like, really?
yeah, we've seen it. We've worked with school districts that just upgraded their whole science wing. They increased their ventilation rates, improved their HVAC system, came back in for their next semester, ran their experiments, and they had to evacuate because the VOC emissions were too high. And so therefore they, spent $500,000 on supplemental solutions like the Halo for, that
They shouldn't have had to.
they shouldn't have to, that they just
Right?
spent
Yeah.
$3 million to upgrade the HVAC system on. So yeah, I mean,
Well, I love a building that was basically torn apart because there was a mold problem and a moisture
yeah,
intrusion problem, and they rebuilt it and they redesigned it with a new architectural team because the original design was terrible, and they come back in, and 2 years later we're coming back in and they're doing mold remediation again because the new design failed. It's like, come on.
yeah, exactly.
And there's not,
Yeah.
like, if that was an isolated case, I would be like, oh well, that was just
No,
dumb people. But no, this unfortunately, my 35 years, I've seen it too many times.
for
So
sure.
so we're almost at the halfway point. So those of you in the virtual studio audience, we're going to be asking you to turn your cameras on in a minute or so, and then we'll start taking some questions from the audience and deal with that. But one question I wanted to pose to Jesse prior to that, so you know if you're out there in the capacity of a facility manager, like, again, we're talking on the commercial side now, not really single homeowner residence type situation, but on the commercial side, you're a school facility, or your healthcare facility, office environment. And again, not talking commercial laboratory environment, because that is a specialized area. So just general office space, or general populations. How should they be looking at, first of all, this is a big question, by the way. How should they be looking at the current needs, to address this pandemic and the COVID-19 exposure, or excuse me, the SARS-CoV-2 exposures? I hate when people conflate that, anyway. So it's, so I can't do it on my own show. But then moreover, how does that equate to moving forward, making decisions that are not just a knee-jerk reaction for now that they're going to pull back on, right? And have it be something that's, like, meaningful in the future that improves the environment. That's a long question.
Basically trying to develop a permanent solution, right?
Exactly. And more than just a COVID, taking this COVID emergency and turning it into something where it's a positive, actionable change going forward.
Yeah. I mean, you have to look at you start with what they currently have in place. What do we need to achieve in order to provide mitigation strategies for not just SARS-CoV-2, but for other viruses and indoor air quality, and also importantly, understand the low density factor in these facilities, because again, it's not just one size fits all approach. So it's really, let's take a look at your reflective ceiling plans. Let's understand how this building is going to operate in the new normal. Where are people going to be positioned, where your airflow patterns are, and then let's work with you to develop a plan and a strategy that's going to be for the long term. We have a great article on a website called The Long-Term Playbook to Healthy Indoor Air. It's just that. What is the long-term playbook? And how are you going to implement that? And that's really what we're doing with facilities directors and managers that are very much involved with all of these decisions, because they're tasked with, hey, find a solution. So it's really, let's understand everything from, entry to the building to exit, where we exit the building, where people sit, where they're located, your air change rates, and let's develop a true strategy for the long term.
It's a challenge, though, right? Because we're going to redeploy people, as far as positions within buildings, and some facilities, some things will change. Yeah. Some things will go back to the way they were. But I think we need that flexibility, right, going forward. Because as you mentioned, and I totally concur, this is not the last global pandemic by far.
Unfortunately,
I know they used to be once in 100 years, and this is our 100-year one. But I think they're not going to be once in 100 years anymore. I think we're going to be looking at more like every decade, some catastrophic event.
We've already been there, right? We were Ebola, H1N1. I mean, these were epidemics, pandemics. I mean, call it what you want. I knew more people that had H1N1 than I did SARS-CoV-2, thankfully. But that was also an epidemic. It wasn't treated the way this is being treated. Obviously, it's much bigger. And
we dodged some bullets on those.
We dodged a lot of bullets.
And I think we got complacent because we got through them relatively unscathed, a few thousand deaths, and which is not to say that's minor, because if you're one of the family, it's one of your family members or your loved ones that was one of those few thousand people, it's not that insignificant. But but again, I think as a national community in the United States, and probably in a lot of other places, you look at it like, that could have been bad, but it wasn't. We're good.
We were that close from it exploding, and that again, we didn't learn our lesson there. Part of it is, Bob, is lack of guidance from boards and committees and governments that tell you
cognizant authorities
what needs to be done. And that's it. We saw it at the start of this pandemic. Wear a mask, don't wear a mask. It's not airborne, it is airborne. Oh, we're going to retract that statement. Oh, it is airborne again. It's just lack of guidance. And we just need somebody to, take hold, take initiative, and truly, deliver us the truth.
Yeah, the agencies. I mean, we in this country, and again, we're talking United States now.
Sure.
We rely on, I mean, we want to be able to rely on our federal authorities and our state authorities to give us the right information. I mean, a lot of stuff got politicized, which is like insane. I for the life of me, I'll never understand politicizing science, but that's another story. To me, science is like Neil deGrasse Tyson says it right. It doesn't matter what your opinion is. Science is the fact.
That's right. That's
And
right.
it evolves. That's the other thing. The
It
fact,
absolutely evolves.
because it does evolve over time, because it's a fact as we know it today based on our current knowledge. And you have to also, science does recognize that there's, the hypotheses are always changing, right? Because the more data you get, you go back and reevaluate, and maybe this was the best we knew at the time, but it's better now,
Right. Absolutely.
Anyway, so we've got some questions in queue. So we'll ask that our online studio audience turn your cams on. Keep your mics off though until you're on actually speaking to us. So we'll start to see some faces popping in. And our first question is coming from a gentleman who popped his camera on, a regular, Terry Sofer. Hi, Terry.
Hi, Terry.
Hi. First off, I want to commend you and Bob for your focus in your comments on the challenges of contaminants in outdoor air and how ventilation can create indoor air problems, not just dilute them.
Thank you.
I would like to first ask you to clarify your filtration technology. Is it purely adsorption media, or is it combined with other technology?
Good question. So we have adsorption media on the chemical fume hoods. We also have adsorption media in the halo above. We don't combine the adsorption and the absorption with the halo yet, and it's because a lot of air purifiers will say we have carbon filtration. That's stretching it. You have to understand carbon filtration. You have to understand, you have to have proper airflow. You have to allow for proper residency time for this to even be truly effective. So for right now, we have two separate halos, one with a HEPA filter and one with a carbon filter. We are in development stages of one that can integrate both with the right airflow, providing the right residency time. We don't have too much static pressure issues with the combination of both filtration. So Terry, to answer your question, it's a combination of both. On the fume hoods behind me that you see, we can integrate both absorption and adsorption media into the fume hood. So if somebody's doing exothermic reactions, working with powders, they can do that and also work on their chemical analytics, whatever they're doing. So it's a combination to answer your question.
If I could just elaborate on that, does the adsorption media include any ability to actually, to destroy biotoxic molecules or
Good question. Nothing's destroyed. Everything's captured and retained. Okay. What we do with some of our technology is we have filtration, pre-filtration before a molecule gets to the actual carbon media, which is coconut shell. And that allows us to slow down the molecule. It allows us to neutralize it if it's an acid. We also have special solutions for ammonia and formaldehyde. Formaldehyde is extremely challenging to capture based on ACGIH standards at 0.75. We have to guarantee that we have released no greater than 1% of the threshold limit value with any of our adsorption media. So understand we have to be at 1% of the ACGIH of any chemicals. Formaldehyde is extremely challenging. So we have to figure out a way to treat the molecule before it gets to the carbon. For ammonias, it's really about neutralizing the smell, the odor, because you're gonna smell ammonia much sooner than you are even at 1% of the threshold limit value. So it does not destruct anything.
I mean, one of the things I would say would probably be very challenging, right, Jesse, is that with like technology, like retrofit technology, like a halo units, it's a relatively small footprint, it's a small device. Whereas your standalone lab capture equipment, they're pretty robust. That's even though it's compact, it's still you have a space to put a lot of adsorbent material there.
Oh, for sure, yeah.
Where you don't really have that in a small ceiling tile grid.
Yeah, the halo is actually not. It's a 2x4 grid. It's about, with the HEPA filter, it's about 8 inches. The HEPA filter itself is about 8 inches thick, so it's a pretty robust HEPA filter. But yeah, on the filter we have, we can layer up to 3 levels of filtration on each fan module. If you see the unit behind me, you can kind of see sections broken up above. So there's actually 4 separate fan modules on that system. Each fan module houses up to 3 filters, a combination of HEPA and carbon filtration. So yeah, it's robust media for sure. You know, you look, this is that point of use capture. So we're capturing at concentration loads. Typically, on average, our filters last anywhere between 24 and 48 months on the adsorption media. So it's very robust. It's technology that's been developed over 50 years. So there's a lot that goes into it. It's not just about the media. It's how is the filters designed? How does the air flow through the filter? How do you ensure you don't have channeling? You don't have paths of least resistance. It's how we engineer even the inside of the filter grid as well. You know, you have to make sure you don't have smooth surfaces anywhere. So there's a lot of technology that goes into molecular filtration. HEPA filtration, again, like I said, HEPA filtration is easy in comparison.
Which is interesting too, because again, you're coming at it from, you know, your history, company's history is coming at it from dealing with the laboratory situation. So high concentrations of constituents, I mean, lab would work very high concentrations, direct capture. So, all the efficiency as far as the airflows. I mean, airflows are a big deal for you guys because with your capture hood, you've got to make sure that you're actually entraining what's in that hood and getting it through your processing, and it's not coming back out in the breathing zone. But there's more. I mean, I think there's more of a nuance with general indoor air quality in office spaces and places like that, non-critical areas like laboratory environments, where we're dealing with, first of all, much lower levels of constituents.
True.
Generally,
Yes.
and usually bigger areas, bigger volumes, right? Because you've got in a lab hood environment, you're kind of in a captive area, or that's the design. Whereas, we're dealing with a general open environment in most spaces with indoor air quality issues. So how from what you guys have learned in the lab control area, how does that play out and cross play into just general indoor air quality issues?
It's understanding how air moves, right? It's not always, you don't always throw more air at a problem and determine it to be the solution. So we learned a lot on the molecular side, and specifically the fume hood side, because we're capturing at concentration loads, but we have to adhere to strict standards, which means we have to ensure we have 100 feet per minute at the face velocity, and we have to do that in a manner in which we have the fans calibrated and where they're not too fast, because if you run air too quickly past that molecular filter, it's not going to capture appropriately. You don't have proper residency time. So we learn a lot there, and we kind of integrated that in all that knowledge into open area space and really what's needed. Air is passive. I mean, it's going to flow. If we have a fan pulling air, the air is going to go there. It's not that hard to get air to the filter media. But that said, you can't just have one unit in an open area. And that's why we have to calculate the space to determine the quantity of units necessary. And that's what really bothers us as well, because, you see a lot of these schools. Oh, I bought a corner unit. It's sitting there in the corner behind the desk, behind student, behind Larry. Okay, well, where's that air? And now you're compromising the integrity of the airflow that unit's supposed to be providing. And not to mention that unit's not giving you enough air processing for that one room. So it's really about sizing it appropriately for the space you're installing it. It gets us into not trouble, but we'll lose opportunities because we say, Bob, you're going to need 15 units. What do you mean I need 15 units? Well, in order for this device to work effectively, you have to understand you're going to need 15 units. And the customers just be like, no, thank you. And then they just go with the Amazon product.
Because that's the problem for general consumers too. Like off-the-shelf solutions, right? At a retail outlet, box store, whatever. These units say, oh, it's good for 1,200 square feet or whatever. I'm just throwing a number out there, and it's like on a general consumer's mind, oh well, my house is 1,500 square feet. That should pretty much do my house, but. No. The airflow patterns don't work that way. It's like, do you live in a single room? Maybe it would work.
In a bedroom, yeah. If it's for your bedroom, sure. Who cares? But not for commercial space. And we don't sell to the residential market because this is not a residential product. It'd be way overkill, right? And it's an install product. It's all commercial based, and it's you have to size it appropriately. And that's part of the education that we're doing, and it's a lot of it.
Well, how to get back to you were talking about achieving ventilation equivalencies. How is that calculated? Just if you share just a quick,
So
quick mindset on that.
each unit draws 170 CFM. Right, so it's 10,200 cubic feet an hour. So you calculate that for every 3,500 cubic feet of space, that's going to provide you with an air change equivalency of about 3.5 air change rates per hour, give or take, plus or minus. And that's really how we calculate it. There's nothing to hide there. And if we push more air through it, it's not going to do no good, because then we just create a turbulent environment. Not to mention the system's going to be way too noisy, and people are just going to turn it down anyway. And that's the other thing. You get a lot of these systems. Oh, it processes 1,200 CFM at high setting, which is at 75 decibels. That's not going to run. That's no way. Right. So I'm going to turn that down to a low setting. No, that setting that we provide you with, that's running at about 54 decibels, 2,800 RPM. It's the sweet spot. Any higher than that, you don't have proper diffusion of smaller particles. You have to worry about that too. So you can't just add more air to the problem and consider it to be the solution.
Well, we get into that conversation not just with air filtration, like even just HEPA equipment in the IAQ industry.
Yeah.
And you got these air duct machines where they put a 24 by 24 by 12 inch pleated filter in
Big,
there.
huge filter, yeah.
But they're claiming they got 4,000 CFM capacity. It's like, you don't have a 24 by 24 by 12 HEPA that can handle 4,000 CFM.
No,
you don't.
No.
I always laugh when I go to trade shows and see that, and I go, that's not going to work. You're either choking the fan or you're going to overdrive the filter. There's no way that works in the real world. Right. Just do the math.
Yeah, absolutely. But the general consumer doesn't know that, Bob, and that's the challenge. They just don't. They're not educated on it. They know what they know, and they never had to deal with indoor air quality issues before.
Well, I would argue the commercial consumers, for the most part, don't understand it either.
That's what I mean.
Yeah. Obviously, certainly the homeowners don't have a clue on most of this stuff. But as a consultant, for 35 years, I walk into commercial facilities all the time, and people are kind of clueless on most of this.
Absolutely. I think it was Patrick just asked a question, but it's not showing up on my screen anymore. If any plans on making a design for, I lost it.
Oh yeah, I've got it here. So any plans on making a design, or would these units be adaptable to replace a HEPA machine in a remediation project? So I think the question is, could these be used as standalone devices for short-term usage in spaces?
Sure. Patrick, yes, the design, we're in the process right now. So we will have a solution that is adaptable to be plug and play essentially, and it will be portable, but it won't be positioned at the floor level. We'll still have it basically on an L bracket almost, because again, airflow patterns, we just don't want to put it on the corner and drive polluted air down past the breathing zone. But yes, it will be more portable than it is today in the next version. We'll still have two versions, because this is absolutely perfect on the commercial setting. But yes, probably towards the end of the year, we're looking at a December launch.
Interesting. Yeah, because obviously your existing product is designed to really be a permanent install. It's a retrofit replacement in the space, and it makes a lot of sense to me, to have something that you get out of the way but still serviceable, because that's the other thing. You can put things way out of the way, and then will the service work that needs to be done on the device be done. And I'm assuming they look like they're fairly easily accessible.
Oh, extremely. There's push pins. The unit drops down. You take the HEPA filter out. You replace it. There's a pre-filter above on the grids that just slides in and out, much like your heating filter. The HEPA filters, 3 to 5 years on average would be the replacement requirement. So you get a lot of time used on these HEPA filters. It's not you don't have to replace them manually. It would be overkill to do that, unless you have an area of high humidity and then you have moisture issues, and you could potentially, then there could be mold spores growing. We don't want that either. So it's obviously depends on the environment in which the halo is installed, but on average, 3 to 5 years would be the regular maintenance.
That's true with any equipment too. Without naming a brand, I've had a standalone HEPA filtered unit in my bedroom running for like 15 years. And I'm real happy with it. And it's definitely a consumer type unit. Yeah. But as far as changing out HEPA filters, I'm not going to lie. I've changed the HEPA filter once in 15 years. I've changed the pre-filters a lot.
Sure.
And yeah, I have the luxury of having a laser particle counter where I can go over and look at what's coming out of the output of this
Right.
thing. And I'm like,
Right.
and I will honestly say, my wife, Christy will go like, why aren't we changing? You IAQ man, why aren't you changing the HEPA filter? I go, you don't freaking need to change. I'm looking at it. It's doing 99% capture here. Why would I change it? The airflow's there. It is loud though. I will say, for a consumer in a bedroom, those end up being a white noise generator. I can't even sleep in hotels anymore without having the sound of that fan. It's programmed in my head, and it's quite loud. So let's get some more questions from the audience. I know we still have a bunch of people out there. We still have 10 minutes left till close, so we could entertain one or two more questions. So here's a question for Jesse here. 2020, obviously, you couldn't have foresaw that in 2019.
No.
What was going to happen business wise and having to do a shift, and was that kind of challenging? I mean, because it seems like a lot of companies faced severe, it was a severe challenge. I mean, how did you guys roll with that? And do you think that's going to make you a stronger company in the long run?
You learn a lot about who you have as employees when something like that happens, right? Because everybody got shifted to remote immediately, and you know what you have. If people are working from home and they're just kind of going day by day and doing the least that they possibly can to get by, you will know quickly. We're lucky enough that we had a team that they took the challenge and they really ran with it, and it actually ended up being a very decent year for us because everybody just worked as hard as they could. I wouldn't say we saw a growth. We didn't. I mean, but we also we didn't regress either. That speaks a lot for who we have on the team. We learned a lot. We learned a lot about, I guess, our moral compass internally.
Sure.
And how people are going to adapt to challenges. We I guess benefited a little bit. I hate to use that word, from COVID because labs, they were still working. They're trying to develop a vaccine. You have PCR tests, all different kinds of things going on in the laboratory where they still needed hoods. They needed storage solutions. They needed the halos for VOC mitigation and things like that. We really didn't start ramping up to sell the Halo HEPA until August to September of 2020. So it really wasn't a big part of our business in 2020. That really wasn't what propelled our business. It was still servicing the laboratories. And that's another thing I just want to point out real quick. When you're looking at solutions, find out what that company was doing before COVID. Please, because if that company before COVID never existed or was not in filtration or whatever, just do your research because there's charlatans out there. Just caution yourself, educate yourself on the company itself.
Well, that's a given in any crisis. I mean, you have a major hurricane up the East Coast, and suddenly everybody and their brother does mold remediation. I mean, that's just
sure.
It's unfortunately the nature of a free economy, or somewhat free economy.
I guess you can't blame them. They're all trying to make a buck, but
that raises an issue though, because again, you're in a more regulated environment when you're dealing with the laboratory environment, right? There's a lot of lots of standards, right?
Yeah.
But when you're talking about providing devices for general consumers, not so much. Right.
No,
I mean, the FTC gets involved, if there's totally false or misleading advertising. Yeah. They don't have very big teeth in this arena. I mean, they purportedly do, but they really don't. I mean, companies over the years, and I won't name the brand and I won't name the technology, but there was a company that was doing technology that was, EPA railed on it several decades ago. The company got fined by the FTC, and then they're back in 6 months under a different brand,
and a different name,
selling the same thing with different logos on it. I mean, it's
it's frustrating. It's the Wild West out there right now, what we're dealing with. I think Tim's on the call. He's my partner in crime here in this division. And it's the Wild West. And it's just shake our heads every day going, my word, what is going on out there? There has to be, I hope there's regulations written at some point in time. Legislation steps in somewhere and writes some sort of, I don't know, guidelines. Of
caveat emptor, it just is. I mean, unfortunately.
Yeah.
Yeah.
Yep, that's what all I can do is sigh sometimes.
I know. Well, me too, as a consultant. I know probably many of you on the call have the same thing. You got all experience these sort of things probably on a daily basis as well. So, obviously you're focused, company's been focused on commercial laboratories and then, on commercial spaces. Are there any plans for you to get into a residential version of some of your technology? Or is that maybe on the future?
We've talked about it. It's just, I don't know if that's right for us as a company. We don't know yet. It's in the talks. We have our meetings, and does this make sense for us? Do we have the bandwidth to handle the residential market? Do we want to? We really want to be seen as true specialists in the commercial side. There's a lot of brand equity we've built in this market, and I don't know if the same would exist in the residential side. We'd have to kind of devalue the brand a little bit too, because we'd have to adjust. We'd have to design a product that didn't really meet our standards in the residential, because you'd have it's price conscious.
No, I mean totally. It's a totally different market, and just the distribution. You'd have to have retail distribution too. That's a whole different thing.
It's completely different. So we just don't know yet. Right now, I would say no, but you never know. You never know what changes.
Yeah, that's true. That's true. You never know what's around next year's corner.
Yeah,
so we're at the point where we're going to wrap this up. So Jesse, I'm going to give you an opportunity to give us some final thoughts, because obviously we ran pretty fast here today, and I'm sure there's at least one burning comment that you really wanted to get in there, or just a final closing overall thought on our discussion today. So I'm going to give you the floor.
Oh, I thank you. I think I've said it is anybody that's looking for a solution, please educate yourself on the technology, do your due diligence, understand the testing that was performed, really dive deep into the results, make sure that it's not, done in a controlled chamber that's a 2x2 chamber, because anything's going to pass. See if there's real world testing, peer-reviewed data. Educate yourself on the company itself, what they did beforehand, how relevant they are, the brand equity, the credibility they have behind them. All of that's very important, because this is a problem that isn't going away. Like I think we said, unfortunately, obviously indoor air quality issues aren't going away. And I just don't see SARS-CoV-2 going away like we all had hoped. So please do your due diligence. I guess that's my leaving statement that I would like to, leave here with.
Hey, those are good words. And yeah, it's not going away soon. I mean, I know we're all experiencing fatigue on this pandemic, clearly, right? I mean, all of us are, but just as what's being evidenced right now in India, I mean, it's just an awful situation there. And we're, yes, I think we're seeing light at the end of the tunnel. And certainly in the United States, things look better than they did a while ago. But, this is still a global problem. So long as there's, this deadly virus floating around the planet, in modifying itself, there's certainly more problems on the horizon, and we all have to address this as a global community. So that's a big deal. One of the things, so I want to take this opportunity just to throw a quick plug in for Healthy Indoors. Obviously, many of you are watching this through our portal at healthyindoors.com, which is where all the issues of our digital publications, our magazines reside, as well as the back episodes and recordings from the Healthy Indoors show and the audio podcasts from our show too. We have all that up there and available. One of the things that you still have an opportunity for today is the 29th. For 2 more days, you still have an opportunity to get a free pro membership to our new online global community platform, which is something that we're going to be releasing very soon to the general public. Again, this is a dedicated platform that will allow you to network and communicate with other people on the topics of indoor air quality. So think of it as a bit more than social media, a lot more than social media, but an area where people of like interests can contribute and speak amongst yourselves, as well as places where we will have a repository of lots of information, live streamed events, yada, yada. It's going to be some great stuff there. We're super excited about this. Can't stress it enough. So that's something to be looking for. And again, if you want to take advantage of that opportunity to get the premium level membership, you still have a couple days that you can sign up and pre-register for that. So I guess without further ado, I really want to thank Jesse for joining us today. This is a great discussion. Again, we never have enough time. I guess, these topics, we You and I could probably go on for 3 hours and not even scratch the surface.
Absolutely.
But I do appreciate your time with us on the show today, and thanks for sharing your insight and what you're coming from. I thank you again to all of you in the virtual studio audience. Thanks for taking time out of your workday to be here for an hour with us. Definitely appreciate it. We appreciate your support and your interest. So until next week, we'll be here again, same time, same channel, 1 to 2 p.m. Eastern time for the Healthy Indoors live show.